Now we're going to see a decision tree project here, which can both be used for classification and regression tasks. And it works pretty much as a tree coming from the root to the leaves, giving the predictions as it goes along. The main thing here is that we're going to use stocks as well. And the main thing here is that weights, it gives weights for every single column that we're going to use as features. So let's go. First of all, we're going to import the libraries. As you can see here, we are using sklearn. We're going to we're going to choose a stock here. Let's use Amazon. We're going to define the start date. Oh, let's change the code of end date here. Let's use date time today. I believe I'm gonna have to import the library. Date time. Let's see if it's going to work. Let's get data from 2010. Okay, so the end date is today. So let's download the data. As you can see here, from 2010 and 2023, which is today. And we are going to now get the percentage change for every single column. There you go, here. Now we are going to establish a database with only those columns. Let's drop the NA values, okay. And now we're going to get the data from tomorrow's percentage change. So we're going to shift the closing date because we are looking for tomorrow's closing date. So let's get this column here. As you can see, this last column here, this one, it has the closing percentage change from the day after. Okay, so let's go on. So we have a none value here, and now we're going to do something different here. We want to know what is the value of the first quantile, the second quantile, which is median, okay, and the third quantile. So we're going to run this code, and the quantiles I mentioned, it's from the tomorrow's column, okay. So let's go on. Okay, so we have the values here. So now we are going to give labels to each one of those data in our tomorrow from our tomorrow column. So we're going to create a list, and if the value is higher than the third quantile, we're going to say it's number 3. If the value is higher than the second one, we're going to establish the number 2, and so on. And then we're going to plot that list into a specific column, which I call it tomorrow reach, okay, in this data frame. Let's do this. There you go. So we have tomorrow reach here, tomorrow reach here. And then we're going to define the class and the features. So the class is the value that we want to predict, which is related to the tomorrow reach column. And the features are the rest of the columns from our data set above. Okay, so let's run this. So now we're going to split our data frame into train and test data frame. So we're going to use only 20% from it as a test and the rest as train. Let's run this. So we are going to use this model here, which is a decision tree classifier. Then we're going to fit the model. Then we are going to check the results on the test database. So let's see the accuracy score. As you can see here, it's a very poor and a low accuracy score. So we're probably not going to use this model to do predictions, okay? Oh, let's see the importance of the features here, which means the weight our model established for each one of the columns that it uses as features. As you can see here, for each one of those columns there is a weight, and we can see that the close one is the one that had more weight in our value, in our model. So now let's make the prediction here. We're going to split the data frame first. Okay, so we chose just the feature values here. And now let's run the prediction. So since the prediction is 0, we can say that the value is between, it is below the first quantile, okay? So it expects a value below the first quantile. So as we saw previously, the first quantile is almost minus 1%, is minus 0.9. So our model expects a value below that, okay? And now let's run the same test here using random forest instead, which is pretty much the same thing of a decision tree, but instead of only have only one tree, it uses a lot of trees. We can establish that. So here, as you can see, we have established 100 trees here. So let's import the random forest classifier. Now let's run our model using random forest classifier. So let's fit it as well. Let's run it on our test database, and let's see if the accuracy score is better than the decision tree one. It is better, but it's not significantly better. So we are not going to be using nor the decision tree nor the random forest classifier here. So that's it, guys. I hope you enjoyed it, and I hope you can improve this model, because we had not really good accuracy scores, but since you can develop it, I believe you can get better results. Okay.